Yeah, I said we were going to record this. Now it's recording. This is going to be on the video.
Hey guys.
All right, so this is the final part of the review for your final exam. You can review SLO1's review and SLO2's review for things that are on the exam. So we've talked about this. The exam is going to focus on chapter 23, 24, and 14. It'll include small portions from other chapters that were included in the SLO review videos already. Something very important is you need to know your units. There are going to be questions specifically asking for the units of things. For instance, the unit for work is what? No, it's not joules, it's not coulombs, it's not joules. We already said that first. Watts. Power, or I'm sorry. Work. I said work?
Yeah.
Oh, man. Yeah, work is in joules. I thought I said something else.
Oh my goodness.
It's one of those fun days. Okay. Know your units. On the test, you are allowed one 3-inch by 5-inch note card. You are not allowed to use your notebook on the final. You are allowed to use a note card. Your note card needs to be made before you get in to take the final. Final for seniors, they have to take it either after school today or before or after school tomorrow or before school on Friday. For the juniors, the final schedule looks like this. On Monday, you'll take your second, third, and fourth period finals. On Tuesday, you'll take your first, fifth, and seventh period final. And on Wednesday, you'll take your sixth and your eighth period final. Okay, so we're going to start by looking at what was in chapter 23, which should be electricity. So there are two types of circuits. There's a series circuit and there's a parallel circuit. In a series circuit, like what you see right here, there is only one loop. It is a single loop circuit. Only one path for the current to go through. Not 2 paths, not 3 paths, not 57 paths. There is one path. So this right here is your series circuit. In a parallel circuit, however, there are multiple loops. I know this looks kind of ugly, but here's a loop. I need to redo this. Here's a loop. You could go this way. You could go all the way through this way. So there's 3 different loops through this one. If I have more than one loop, I am dealing with a parallel circuit. If I only have one loop, I am a series circuit. The important thing about those is that the resistors in them add up differently. In the series circuit, to calculate the equivalent resistance, you just add up each resistor. R1 plus R2 plus R3 gets you your equivalent resistance. In a parallel circuit, however, you add their inverses. So you get 1 divided by the parallel resistance is 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R ... forever and forever and forever. Okay, so in a parallel one, we add up their inverses. You do 1 over RP equals 1 over R1, 1 over R2 plus 1 over R3, and forever and ever. So one of the common problems that people were doing when we did this before is they would do this side of the equation, and they would write that as their answer. But that side of the equation doesn't get you the answer for what R parallel is when we're simplifying a circuit. This side of the equation gets you 1 over RP. So how do I get it to just R parallel? I divide it by 1. We do 1 divided by this answer. So 1 divided by answer on your calculator will get you to where we need to be, which is just RP at the end. That's something a lot of people struggled on. They were doing all the stuff on the right side of the equation, and then they just stopped there and wrote that as their answer for their parallel resistance. Remember, on your calculator, after you add them, do 1 divided by answer. You know, the control button and then the negative button. The blue control button and then the negative button that says blue ANS for answer. You know, trying to help y'all out and whatnot. On the calculator. Oh, I'm sorry. On some of them, it's a yellow control button, and then it's written in yellow. All right. Ohm's law, or for those who are bad at math, Ohm's 3 laws. We got V is equal to I times R. That's Ohm's law. Voltage is equal to current times resistance. Now, if you're bad at math, Ohm didn't have 1 law, he had 3 laws. It's a hilarious joke. That is why you're all laughing. Yes. Okay, so V is equal to I times R. Rearranging that equation, you get I is equal to V over R. Rearranging again, you get R is equal to V over I. Now, Ohm's laws work really well if you have a simple circuit, which is why whenever we have multiple resistors, we like to get their equivalent resistance, make them the easiest, simplest circuit that we can with just one voltage source, just one current, just one resistance. Okay? After we do all that, there's power. The equation for power is P is equal to I times V. Power is current times voltage. Power is current times voltage. Substitute in Ohm's law for voltage, and you end up with power is equal to I squared times R. Substitute it in for the current, and you end up with V squared over R. So power can be written 3 different ways. Again, it's all the same thing, just like Ohm's law is all the same thing. And we should know that power is nothing more than just the energy divided by the time. It's the rate at which you're using energy. I stands for current. R stands for resistance. V stands for voltage. Okay. Next thing we have is electrostatics. So when we're doing electrostatic force, we use this fun, simple equation, F equals K Q1, Q2 over R squared. So electrostatic force is the constant times charge 1 times charge 2 divided by R squared. Now the K stands for constant, and the reason it's K is because obviously you spell constant with a K. Everyone knows that. Good, y'all are picking up on jokes now. K is just a common letter that they use for constant. They don't like to use C because it stands for the speed of light, or capital C because it stands for capacitance. So they, use K. And a bunch of different constants use K, just like the spring constant uses K. Okay? Now, K for electrostatics is 9 times 10 to the 9th Newton meter squared per Coulomb squared, which means that my force is going to come out in newtons. My charge has to be in coulombs, and my radius has to be in meters. If you have anything else, you're going to get a wrong answer. So make sure you convert. The next thing we covered was magnetism. For magnetism, if we're talking about the force on a current carrying wire, it'll be F is equal to ILB sine theta, where F is force, I is current, L is the length of the wire, and B is the strength of the magnetic field, times sine of the angle between the magnetic field and the current. L is the length of the wire. Okay? Now F is equal to QVB as well, where Q is the charge, V is how fast that charge is moving, and B is the strength of the magnetic field. Again, times sine of the angle between those two things. Could be. Okay. Now, whenever we're doing these things, we need to know the right-hand rule so that we can tell where our force is going. So, when using the right-hand rule, the thumb on your right hand goes in the direction of either the current or the moving charge. The fingers of your right hand will then represent where the field is. And then your palm will show you the direction of the force on a positive charge. If you have a negative charge, it just goes the opposite direction. Okay? Now, if this is just a magnetic field that's being induced in a wire, you still use the right-hand rule. Your thumb will go in the direction of the current in the wire, and your fingers will curl in the direction of the induced magnetic field. So it's still the right-hand rule. Next thing we have is waves. Chapter 14, everyone's favorite. Lambda equals V over F, and lambda stands for wavelength. Very good. V stands for velocity, and F stands for frequency. And then a little bit extra. The F can be calculated as 1 divided by the period. And the period can be calculated as 1 divided by the frequency. Not so bad. All right. Lowercase f. Okay. So we got all the equations for this third section. Let's go and do a couple of example problems. All right, so we have an electrical circuit. What type of electrical circuit is this? Series, how do I know? There's only one loop, so I know it's a series. Only one loop. If I start going through this circuit, there's only one way to get back. You know, I don't have anywhere over here where I can jump off and go this way. You know, that's not on there. All I have is one loop. Okay? So they want me to find current. What did they give me? They gave me 9 volts, and what is that? My voltage. What else did they give me? They gave me a lot of ohms. They gave me R1, R2, and R3. Nope. All right, so they want me to find the current. Well, if I'm going to find the current, I got to find what the total resistance is first, right? You know, V, I, and R. Yeah, a lot of people are doing this in their head right now to find the total resistance, but I'll show it in, you know, just in case, because this is a review. So R for a series circuit is equal to R1 plus R2 plus R3. So that'll be something we solve in just 1 second. Then I is equal to what? Use one of Ohm's laws. I equals V over R. All right, so we go to solve. We do the series first. Our series is equal to 100 plus 300 plus 50 equals 450 ohms. And then we just do I equals V over R. V was 9. R was 450. So plug 9 divided by 450 into your calculator. .02. Check our significant figures. There is only one, so that means that's good. What unit goes on current? Amperes, capital A. Put it in a box, that's it. Okay. So that was the first thing it asked us to calculate. It said calculate the current. What's the other thing it wanted us to do? Calculate the power. Well, if we got the current and we got the voltage, power ain't going to be no thing. What's the equation for power that involves current and voltage? P equals IV. So solve it. Power equals 0.2 times 9. Zero point 0.18. What's the unit for power? Not joules. Watts. Nine squared over 450. So 81 divided by 450. Yeah, you get the same answer. You got 9 over 50 on that calculator. If you approximate that back to an actual answer, you get the same answer. What's up? I don't know. No. We're like recording a lesson right now. Yeah, I don't know. There's a lot of leeway on exemptions in the handbook. All right. We're going to do one with electrostatic force now. It says 2 balloons are charged with an identical quantity and type of charge, negative 6.25 nanocoulombs. So, given charge 1, it says it's identical with the other one. So Q1 is equal to Q2. And they are both equal to negative 6.25 nanocoulombs. They are held apart at a separation of distance of 61.7 centimeters. So R is equal to 61.7 centimeters. And they want to know, what is the electrostatic force between them? Oh. I don't know. Okay, so what do I have to do before I can solve this problem? Convert my nanocoulombs into coulombs. What does nano stand for? Yeah, but how small? No, negative 10 is too many smalls. Negative 9 is the right number. And then centimeters, 61.7 centimeters is 0.617 meters. All right. The equation F equals K Q1 Q2 over R squared. We go to solve. What did we say K was? That's right. It was 9 times 10 to the 9th. Q1 is negative 6.25 times 10 to the negative 9th. Q2, negative 6.25 times 10 to the negative 9th. Divided by 0.617 squared. We just plug it into our calculator. Probably want to follow along. So 9 doubly 9 times negative 6.25 . 6.25 double E negative 9 times 6.25 double E negative 9 divided by 0.617 squared. I get F is pretty small. It was 61.7 centimeters, but we converted that to meters. I got 9 point. What'd y'all get?
9, 2, 3, 4, 9,
Yeah. This is why it's important to convert at the beginning. 9.23 times 10 to the negative 7. And what's the unit for force? Newtons. And is this going to be attractive or repulsive? Do we have like charges or unlike charges? We have like charges. Two of them are identical. They're both negative, so they repel or repulsive. All right. Next up, a wire that is 0.75 meters long, carrying a current of 8 amperes to the east, is at right angles to a uniform magnetic field pointing up. The magnitude of the force on the wire is 1.20 newtons. What is the strength and direction of the magnetic field? So they gave us 0.75 meters, and that is the length. Current I is 8.0 amperes, and it's going to the east. Theta, since it's at right angles, is 90 degrees. The force is 1.20 newtons. So they want the strength and the direction. Oh, I needed to put that it was current going. Oh, the field is going up. Oh, man. Made that too easy. It asked for the direction of the field, and we already gave the direction of the field. It's up.
Oh.
I don't know. Okay, so we still need to calculate what the strength of the field is. So that's the given. The unknown is B. The equation F equal I L B sine theta. So the force is 1.2 equals I, which is 8, times L, which is 0.75, times B, which is unknown, times sine of 90, which is actually just 1. Solving for B, we divide 1.2 by 8 times 0.75 times 1, which is what sine 90 is. So I'll just throw it in the calculator again. 1.2 divided by parenthesis 8 times 0.75 times 1, and I get 0.2. Can anyone tell me Whoops, sig figs, 0.20. Can anyone tell me the unit for field? Teslas. All right, and since it did ask for the direction, what direction was the field going? Up. I think this was supposed to say that the force was pointing up, but, you know, screwed up there. Okay. Solving for B right here. So solving for B, the 8 was multiplying times it, and the 0.75 was multiplying times it. So I did the opposite, I divided by it. This 1 right here is because it was multiplying by the sine 90, and sine 90 is just 1. You can always go back and look at this video later. I don't need to make the video 40 minutes long because people write slow. Yes. All right, we got a sound wave produced by a loudspeaker is heard 1,030 meters away, 3.00 seconds later. So, 1,030 meters is what? Distance. 3.00 seconds is time. All right, so the first unknown for A, based on these measurements, what is the speed of sound in air? So my unknown is velocity. Equation. Velocity is v over t. Solve 1,030 divided by 3.00 is equal to what? Huh? Y'all have calculators. Use them, please. So we got 343.3 repeating meters per second. How many sig figs did I have? 3. Okay. Yes, this was on your test. Oh man, this whole part wasn't getting audio. Y'all didn't tell me you couldn't hear my microphone. And we get 0.3937. You see, you didn't use 343.3333333. So you should get 0.39373 something, which means this rounds to 0.394. What's the unit on wavelength? It's a length.
Oh, haters.
All right, that's it for the review today. Sorry for the microphone issues on this last one. I'll go through it really quick. They gave us the distance. They gave us the time. They asked for the velocity. Velocity is distance over time. 1030 divided by 3.00 is 343.3 meters per second. The 3 is repeating forever and ever. Rounded to 3 sig figs, you get 343. Then they gave us the frequency of 872 hertz, asked for period. Period is 1 divided by frequency. Plug it in. We got a long number. Rounds to 0.00115 seconds. The last one was the wavelength. Wavelength is equal to V over F. Lambda is equal to 343.333 repeating forever divided by 872, and you get 0.394. You would have gotten a wrong answer, 0.393, if you rounded your 343.3. Remember, don't round until the end. You could have gone back up in your calculator and just clicked the answer that was the 343.3 repeating, and then divided by 872, and that's how the cookie crumbles and whatnot.